Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now let's move to chapter 9. That is called Sinusoid and Phasors. So we move to the last class. You learned about DC, direct current. So now we move to the alternating current. So what you will learn in this chapter, first is the concept of sinusoids, and then we transfer to the concept of phasors. So you will learn also in the previous chapter, you only learned about resistor, right? Okay, in the previous chapter, you learned about only R. So now in your sinusoid or in your phasor of the second element, we will introduce you what is the inductor and what is capacitor. So all these elements R, L, and C, you're going to analyze it in terms of what we call impedance or admittance, and then you are going to apply Kirchhoff law, KCL and KCL in the frequency domain in the combination of R, L, and C in the circuits. Okay, what is actually sinusoid? So you learn about sine and cosine, right? So all these are varying with the time. So it will repeat by itself after it go into this part. So this is what we call period. So this is one period and this is a second period. So it will repeat by itself according to the time. So how you're going to determine? So here we have what we call R, and here is the capacitor. So the function of the capacitor is store the charge, and you're going to connect all in series with the voltage supply. So how are you going to determine the IT and VT that is varies with time? So the last chapter that you have learned from chapter 1 until chapter 3, all we concentrate on the DC. What is actually DC? So this is the graph time. So let's say this is 5 volt voltage supply, right? So this voltage does not depend on time. Doesn't matter at time equal to 0 or time equal to 5, the voltage will remain the same. So this is what we call DC. So the thing that you learned previously is all about DC circuits. So now we are moving to the what we call AC. AC means the alternating circuit. So either it is sine or it is cosine. So it is varies with time. So we have here IT and VT. Okay. So why it is important to learn sinusoids? So there are two main applications in the electrical engineering. Number one is the energy systems. For your information, the power that you get to charge up your laptop or your handphone is come out from the power line, right? So you need to have a long distance. So this is, for example, the power at the TNB to come out to your home. So the distance is quite far from the power line to your home. So in order to have the efficient distribution, so the transmission of the power from location A to the location B need to be in the form of AC signal, AC. Why? Because this sinusoid or this AC is good in transmit or distribute the power in a long distance. Okay, so we can't transfer the power in using DC. So AC is very efficient in transferring the energy from one location to another. So we use this in the energy systems. Second application is the communication systems, where you know about FM and FM radio, right? This is what we call radio wave. So in order for you transmit the wave from one location to another location, we need what we call a carrier signals. So these carrier signals in communication is what we call sinusoid. So that's why this have been a clear view why you need to learn this sinusoid signal. Okay. So this is just an elaboration. First is the energy system. Second one is the communication in your Wi-Fi, in your radio signal, in your cellular phones, right? All using the carrier signal, which are sinusoids. The last one, so since you are all in the mechanical engineering, right? So you learn about vibration. So all this vibration, the spring constant, all is actually in the sinusoid. So it will change by, the amplitude will be changed by time. Okay. So what is actually sinusoids? So sinusoids comes from the sine or cosine wave. So we see how this function relate to sine and cosine wave. So let's say this is your sine function. So you have here voltage in terms of volt, and it changes with time in terms of seconds. So what is Vm here? Vm is the amplitude. What we call here? Amplitude. Amplitude of the sinusoid from 0 to the peak of the sinusoids. Okay, then you have here sine. So this is a sine function. And you have W here. So what is W here? Is what we call angular frequency. So, and the Wt is the argument of the sinusoids. So, what is angular frequency denoted by W? So, let's see the visual presentation here. So, there are two graphs here. One is the dotted line, one is the straight line here. So, the straight line here denoted by V1 is equal to Vm sine omega t. So what is Vm here is the amplitude. What is the sine omega here is the angular frequency. So how you relate this angular frequency to the frequency is actually omega is actually 2 pi f. Okay, so then you can get f frequency equal omega over 2 pi. And the last one, that is the frequency. Okay, let's say, and then how you relate the frequency and the period. What is period? So let's say this is one cycle, and then you have another cycle. So the distance between one cycle is what we call period, and then we have another period here. So how you calculate the period here? T is the period. It's actually inverse of the frequency, that is 2 pi, this is 1, 2 pi over omega. So the range here is actually 2 pi over omega. Same with this circuit. This is one cycle, right? So one cycle here is 2 pi. So one cycle here is 2 pi. So what? 2 pi over omega. Okay. Okay, now let's see with the Vm. Now V1 start at 0. Now Vm is a bit earlier by having what we call here phase. So this is either will lead goes to the word that is what we call lead and lag. So if you see here, Vm and V1, if you compare which one is leading, so Vm leads because Vm comes out earlier, right? And then goes V1. So Vm leads V1 by what? By theta. Okay. Then what is the function of this? Sorry, this is not Vm. This is V2. So this is V2. Okay. Then what is the function of this V2? Since V1 is Vm sine omega. So V2 is, again, the amplitude is the same. There is no changes. Sine omega t. But there is a phase shift, right? So plus phase shift. The phase. Okay. So this is the important formula. So what is a period? So it need to complete one loop. So the whole loop here is actually the period. We call this one period. What is the relation? 2 pi over angular frequency. Now how you relate this angular? This is what we call angular frequency to cyclic frequency. So cyclic frequency is 1 over T, 1 over period. So you can get here W over 2 pi. So the frequency measured in hertz. How the cyclic frequency. So here we have another cyclic frequency. one period again, and then it repeat by itself, another cyclic frequency, and 1 over t. Okay, now we would like to see the last function. So f equal w over 2 pi. So now how can you relate w and f? Just multiply. W is equal to pi f. So this is angular frequency, this is a cyclic frequency. Okay, so these are the important concept, and the last one is the phase. So how you get the phase? So let's say this is V1. The phase here is start where? It start at 0, right? So this one, the phase is equal to 0, no phase. So let's say it start with 25, and then you can have another graph here. So what will be the graph here? V to t is equal to Vm sine omega t minus 25. So this is what we call the phase. So how you can get the value of the phase? Wt minus 25 equal phase equal the phase. So the phase here is actually 25. Okay, sorry, minus 25, because this is minus. So that's why we get here minus 25. Okay, so we see this example. Okay, let's see this example. So given a sinusoid 5 sides, so let's try to draw. So we have here 5, this is v, right? Or it didn't mention. This is time in second. Calculate its amplitude. So amplitude is equal to 5. Okay, so what will be the phase? Okay, so the phase here is, so the original formula is sine omega t plus phase, right? So how we can get the phase? Phase here is minus 60 degree. How about the angular frequency? This one done. Omega is equal to pi f. So you know here, from here, omega is actually, this is tt, right? So omega is equal 4 pi. 4 pi. The unit is radian per second. Okay, and what is the period? T is equal 1 over f is equal 2 pi over w. So you just divide by 4 pi, so it becomes 0.5 seconds. So what does by 0.5 seconds? The whole period here is 0.5, and the last one, what is the frequency? 1 divided by 0.5 is equal to 2 Hz. So this is the frequency cyclic. This is the angular frequency. This is the period. This is the phase, and this is the amplitude. Okay, so this is for the leading and lagging. We go to the next video. Okay, so that's all for today. Assalamualaikum.